Am I audible? Okay. Greetings. My name is Darius Singh, and I'm a third-year student from Maths Department, Sri Venkateswara College. Today, I'm presenting a holistic, hybrid, adaptive, geometric, deep learning, and perceptual fashion recommender system with applied metaverse for size-fit problems in online shopping. This was also presented at the 9th International Conference for Business Analytics and Intelligence held at IIM Bangalore in December 2022. Next slide, please. These are the table of contents. Next slide, please. Okay. Clothing is the most frequently returned item on e-commerce platform. In India alone, the return rate is about 25 to 40%, with clothing being the major contributor. Also, size fit is a prime issue in these returns. Key factors that influence a purchasing decision of fashion items: appearance of the clothing item on the user's body, garment fit and how well it complements the user body, and user fashion and style preferences. Next slide, please. A review of related work. Fashion recommender systems have been modeling recommendations based on multiple approaches. Some of them are here. So based on fashion item representation. That is basically modeling recommendations based on images, videos and reviews. Apart from this, modeling recommendations based on fashion item compatibility. So that actually means when you're recommending based on item compatibility, whether, okay, so I have a kurta, right? What will be recommended with this kurta? Should I recommend it a jeans or should I recommend shorts? So that is something related to fashion item compatibility. Then is recommendations based on personalization and fit. So based on the user's body type, shape, recommendations are modeled. And based on their personal traits and social media, generally recommendations are modeled. Then another research direction is interpretability and explainability, where recommendations are made based on, not only recommendations are made, but the reason for approval or disapproval of an outfit also made, so that the user can make a more informed decision. And the last research direction is based on social media fashion trends. The drawbacks of all of these are they don't model sizing, compatibility and fashion preferences simultaneously. Some do one, some do other, but not all together. There is also a lack of visualization. Next slide, please. Now taking a look at previous work in monocular virtual try-on. Monocular means single image, based on a single image. So, and virtual try-on is basically the superimposing of clothing items on top of a body. So there are two general ones for which are relevant to our context. That is 2D virtual try-on based on images and 3D virtual try-on based on point clouds or meshes. Drawbacks, it's all relative. There is no geometric aspect to it. And there's a lack of fashion modeling and compatibility. Next slide, please. Now introducing our approach. The holistic, hybrid, adaptive, geometric and perceptual fashion recommender system has 3 modules functioning in succession. The first is the fashion preference module that models the fashion and style preferences of the user. The second is a virtual try-on module that takes those recommendations and provides 2D and 3D virtual try-on representation. And the third module is the geometrical and perceptual fit module, which essentially geometrically and perceptually evaluates the recommendations. Next slide, please. Coming to the fashion preference model. The fashion preference module uses implicit and explicit user feedback. So what is implicit data? Implicit data is data collected from the users. So that would be their screen time, their clicks, their previous order histories, right? And what is explicit data? Explicit data is user data provided by the user, reviews, comments, ratings, all of that. So the fashion preference model uses implicit and explicit user data to model fashion and style preferences of the user, model item fashion compatibility. That is again kurta matching with jeans instead of shorts, right? And it filters, sorts and subsets the comprehensive fashion catalog of an e-commerce platform. Next slide, please. Okay, this is not very clearly visible. I don't know why, but mathematically, for a previous purchase, that is the ith previous purchase, essentially the 3 recommender systems work in conjunction to provide recommendations based on similarity scores for the previous ith purchase, and Ri is the intersection of these sets of recommendations. These sets are also ordered based on a similarity score, that is Sij, if you can see over here. Basically, it is a weighted average of the three similarity scores of the three recommendation systems. So essentially, a similarity score would be, is item I similar to an item J, right? After that, we do the same for up to n previous purchases, and after n previous purchases, we take an intersection of those sets to give the final recommendation set, which is item compatible and also models fashion preferences along with style preferences of the user. Next slide, please. Once these recommendations are passed through the fashion preference model, they move on to the virtual try-on model. The virtual try-on model provides a 2D and 3D virtual try-on representation of these images. So 2D virtual try-on representation would be an image, and 3D virtual try-on representation would be a point cloud. Next slide, please. Okay, this is not at all visible, but essentially two images are taken together. The image of the full body of the person along with the image of the clothing garment. Virtual try-on occurs, there's some pre-processing and post-processing steps, and then the 2D virtual try-on representation is shown, and a 3D virtual try-on mesh is made. That mesh is then post-processed into a 3D virtual try-on point cloud. Next slide, please. So this is just a rough demonstration. For example, there's a full body image of a person. There's a garment image. On the left, you can see that's a 2D virtual try-on image, basically. And the right, there's a screenshot of a 3D virtual try-on point cloud. Next slide, please. Now coming to the geometric and perceptual fit module. We in the geometrical and perceptual fit module, essentially the full body image of the user is again taken, and the 21 body measurements that are shown in this chart are accounted for from that image, and user garment geometric matching and user garment perceptual fit score is accounted for to give the goodness of fit score. Next slide, please. So it looks something like this. Essentially, once you get the full body measurements along with the garment measurements, taking into account the type of fit, that could be slim, regular, relaxed, mathematical matching occurs, and then you get the goodness of fit score. Similarly, a classification model essentially based on the type of fit perceptually rates it to give you the perceptual score that is aggregated to give you the final goodness of its score. Yes, sure. Mathematically, essentially, is the adjusted measurements of the user that depend on the body measurements. The function that L geometric loss is essentially a metric in R that is aggregated using averages, and then you get the basically geometric score. Similarly, you get a perceptual score that is also between 0 and 1. You average them, and based on explicit feedback, if there is any by the user, another factor is added to give you the final goodness of its score. That gives the recommendation score. Next slide. So concluding, applications of the fashion e-commerce are basically reduced return rate, improved user experience, and developing a comprehensive user size fit data set for the Indian market. And also when they are combined with IoT mirrors and augmented reality applications, they can provide physical virtual try-on and physical stores for ease of use, and a framework for update of metaverse character models. Whenever a person uses the virtual try-on module, their module or digital twin will be updated simultaneously. Please go ahead. This is these are screenshots of an application that is using this research to build a product, which is called the Simiverse project. Next, please. Value addition is basically reducing 5% return rate can add to 200 points improvement in the net margin, which can be used to add various features or reduce the price of the products. Next. That's just a recap. And for future work, a streamlined architecture for the same that is more computationally efficient can be added, and the aspect of interpretability and explainability can also be added. References, and thank you. Next. Any questions?
What kind of exact packages you have used here?
So basically, if you go to the slide where we have geometric loss. It's essentially just modulus basically. So our basic metric, right? Absolute metric. And then we have converted it to scale it down between 0 and 1, right? So it's dxy by 1 plus dxy. And then we have taken another, go behind the, wait, no, ahead. Yes. So the standard metric, you can see on top, where somewhere over here, that's the standard metric. And then we have taken the standard metric over 1 plus standard metric to make it between 0 and 1. And then 1 j upon garment is essentially a function that says that if the jth measurement of the garment exists, we take a value 1, otherwise we take a value 0. So that makes it into a loss function from a metric.
It is a 0 1 function?
No, it's a standard metric which is converted into dxy by 1 plus dxy.
Normalized.
Yes. Yes.
So that, the second thing, you have already mentioned some drawbacks. What do you think about to improve the drawbacks?
Yes. So the main drawback is that moving this to production, to actual production environment, is not very computationally efficient. So at this scenario, the best thing to do would be to scale it down and then make it more efficient in that process. Another drawback that I have not mentioned here is called the cold start problem. Essentially, you can get all of this recommendation for a user who's already there in your platform, right? If there's a user who's new, you don't have any information about previous history, what do you do then? That is where you use social media trends. So you find the general trend and then you give a recommendation, and based on that recommendation, you can further model future recommendations.